What is up, guys? It's your boy Pythonwithsean, and today we're back with another video. So I did go back and revisit the solution for reorder list, and the idea for the solution I used last time, which was yesterday, was that I reversed the list, and then by reversing the list, I was able to actually collect kind of group them together. This was the solution I used yesterday. For the solution, I created a copy, I reversed the copy, and then I kind of like merged them together. Well, with that solution, the time complexity was linear and the space complexity is also linear. But for the solution of today, it's actually linear. The solution I watched of Leetcode is actually linear time, linear space, and the idea is we're trying to find the middle value. Kind of reverse everything before that, so it becomes 5, 4, and we kind of merge 1 with this, 2 with this, and then 3 comes after, right? And that's the kind of idea. And this is the code. I'm not gonna like go into it because I already solved this problem yesterday, and this is just me knowing the optimization. Hopefully, if I do come back to this problem another time, I will be able to solve it again. But yeah, I understand the intuition around it, where we're finding the middle value, we're kind of reversing everything before that, so we have like two separate arrays the way I've created it, because I actually set the slow.next equal to none. So I'm kind of like making these two separate things, and then we're actually kind of merging them again together to make this reorder correct. So I won't go into that because I already solved it yesterday. But yeah, let's go into the next problem, which the next medium problem, which is the remove the nth node from the end of the list. So the idea is, now let's quickly put a timer on quick. I've never solved this problem before. Oh wait, I have solved this problem. I've solved it in 2024. What? When did I do this? Anyways, it doesn't really matter. I wasn't even I was so confident I hadn't done this problem, and then when I open, I just see solved. I'm like, huh? When did I even do this? Okay, so given the head of a linked list, remove the nth node from the end of the list and return its head. Right. So here we want to remove the nth node, which is, okay, so 0, 1, 2, we want to remove, wait, no, from the end, okay. Alright, so we want to remove the nth node from the nth last node, okay. So this is 1, 2, we want to move the second last node, right? So we're kind of removing from the end here, and yeah, so we need to try and solve this. Yeah, so nodes, amount of nodes in the tree. Number of nodes, it's okay. So we are at least given 1. Well, so if there isn't a head done next, then and n is greater than 0, then return none, because there'll be nothing to remove. We just remove the only node, right? Right, so yeah, so there will be at least one node. Okay. Yeah, so I wouldn't be doing too much Leetcode today. After I'm done with this problem. What's the next problem, actually? The next problem is copy list with random pointer. Okay, I will probably do that tomorrow, because I actually want to start doing some Go development. I'm actually trying to build a key value store with Go. This is really funny because I built one already using TypeScript, but it definitely isn't going to teach me. I have this friend in my university who's like really good with backend development and like system design. He has servers that's being hit by like thousands of people a day, and he was showing me, like, he was giving me some advice on like what I can start building. And so like he told me to build this using Go, and this will like help me a lot with like backend development. So I want to start building this. If you do want me to like record me building stuff like this, yeah, please let me know in the comments, and yeah, let's actually start solving this problem and see if we can get it done. It's been 2 minutes. I've been yapping for so long. Okay, so we're given a head of a linked list, and we want to remove the nth node from the end of the list of its head. Okay. There is, well, so from the pattern I just learned now, we know how to get the middle of the list, which in this case it's we use a fast and slow pointer, right? So the fast will always go 2 times here, and the slow would always go once. So the question is now, how do we remove the last element? Well, when n is equal to 2, we can see that the fast pointer moved 2 times, right? It went 1 and then it went 2. At that point in time, my slow pointer, as I've moved here, my slow pointer moves here. As I move here, my slow pointer is here. And what do we see? The slow pointer is 1 position before the node we want to delete, right? So when we're here, the slow.next can just equal to the slow.next can equal to the slows.next.next, which will essentially delete this node from the linked list. So that's just some intuition here. Not sure if that's going to work. So if I do have 1, 2, 3, 4, 5, and I have n equals to 2, I move my fast pointer twice, and my slow pointer as well, and my slow pointer will be here, and then I move my slow pointers next to equal to the .next, and the .next is null, then it doesn't really matter because we essentially are still deleting the node from the linked list, right? Does this work all the time? So what if I had 1 maps to 2, and I wanted to remove 1, right? So 1 here means I want to remove the first last node, so I want to remove this node. Well, when I start this, the fast pointer is going to be here, the slow pointer is going to go, the slow pointer and the fast pointer are going to start here, the fast pointer is going to go here, and the slow pointer is going to go, well, it's going to go to the next, so it'll actually be none here, and then the slow pointer is actually 1 node, before the the node we want to delete, so we can just set the .next here to be the .next, right? But what if I put 2 here? That would mean I want to delete 1, right? How would that work? Well, the fast pointer would move .next. Well, we can't go anymore because now our fast is out of bounds. And what does that tell me? We want to remove, is that even possible? That's the question. Because now we basically have that, and that isn't the yeah. So again, we didn't get to move up to n times. So if that happens, we know that we're kind of in a weird condition. So that is an extra edge case just by looking at the problem. If I had an odd number, let's say I had an even number of thingies, right? So I have something like this, right? Right, so we're trying to remove, do I have some water? I'm so thirsty. I don't have water, but anyways. Okay, so suppose I wanted to remove n is equal to 2. Well, this fast pointer will move twice. So the slow pointer and fast pointer will start here. The fast pointer is going to go to the .next. The fast pointer is going to be here. The slow pointer is going to go here. The fast pointer is, and in this case, we actually do want to remove this node, right? So the fast pointer will then go to this point, right? Right, the fast pointer can't go anymore because there isn't a .next here because .next is none. So actually we only did that once, right? But if we did it twice, it'll be okay. So fast will go here, and then slow would go here, and then fast will go here, and then slow will be here, right? But then now we're no longer at the node. We're no longer 1 node before what we're trying to remove, making it a bit more difficult. Yeah, the same thing happened here. When the fast pointer, when the length of the array is odd, it makes the problem very simple. But when the length of the array is an even number, then it just makes it very weird. Because like in this example, the length of the array of the list here, array. Sorry, I'm not saying. I don't know why I'm saying array. Well, the list here is actually an even number. So when we have to delete a node, which is just to quickly check. I don't know. Like if this was an interview, like I would actually clarify this with the interviewer. But I want to confirm if that's what this will return. This should be an empty. Yeah. So it only removes one. Okay. Yeah. So yeah. Okay. Yeah. So it only removes one, which is what I was thinking. Right? And then when n is 1, we want to just remove this node. Okay. Yeah, so let's try and actually let me lock in here. Sorry, I'm getting distracted because I'm so hungry. But let's actually lock in. So n is equal to 1 here. Right? And let's just look at this example first. Well, if I initialize a slow pointer here and a fast pointer here, let's kind of keep track of how many times the fast pointer is moving. Well, the fast pointer is going to move once, right? So the fast pointer is going to start here. It's going to go to .next. So it's going to be here, which is null. And the slow pointer is going to move here, right? So in theory, we could simplify the problem. Right, so the n can't be. Yeah, it can be 0 because if there isn't any node, if there isn't any head on next, then well, if it was 1, then we would remove it. It can be 2 because even if it was 2, we're still returning none, right? And then we could also have but yeah, we don't want to like manually do that. We could generalize the problem to having, when you have a even number of nodes and an odd number of nodes. And how do we know if it's an even number of nodes and an odd number of nodes? Because I noticed that when it's an odd number of nodes, suppose I wanted to delete n is equal to 3, right? Fast is gonna go here, fast is then gonna go here. So slow is gonna move here. Fast is here. Fast is then gonna move here, while slow is here. So slow in this case is actually at the point where we want to remove. What's another way we can do this? Okay. If this was the end of a linked list, right? If this was an array, how do we do this? We'd kind of like go at the index. So if we know we're removing from the last, can we kind of reverse the problem? So what if when we have something like this, right? We have 1 maps to 2, it maps to 3, maps to 4, maps to 5. Do we need to like do any, can we not just reverse the list and then we'll have 5, then 4, and then 3, and then 2, and then 1, and we're trying to delete the third node, right? So it would only go up to n minus 1, right? Which would be, so, right, would go up to here. Then the next would just be, right? Because once we reverse it, we need to make sure that we set the .next to be this one, right? So now we've essentially removed this node, and now we have this, right? We're happy, and then we put it back in the right order. Let's see if that's the same case in this example. So when we had 1 mapping to 2, and the n here is equal to 2, which is a very weird case. I know it's really weird. If I flip it, then I have this, and I want to go all the way to n minus 1, so I'd actually go up to here, and I would actually delete this node right here, and then I'll just return this reversed, which would just be this node, right? And the same thing here, when we reverse it, would have what? Would have 2 maps to 1, and we want to go up to n minus 1, which would be 0, so we essentially need to delete this node, right? And then kind of like return only 1, right? So that's one edge case. So when our n is equal to 0, then the problem kind of gets a bit weird, right? So my intuition here is that I'm going to first let's see if we can do the same intuition here. So we have something like this, right? Right, we want to delete 4. Well, we need to delete the nth node, so we can just go this way, and then we'll go all the way to n minus 1, delete this node, which will give us this, right? Because this is the second to the last node, so we'll only have that, and then we reverse it back to how it was before, and then return that, right? So the idea is kind of like, but there is one edge case we do need to look out for, which is when n is equal to when n is equal to 1, then this becomes weird, right? Because when I reverse it, it becomes easier for this, right? Because we can remove so we can remove the 1 easier here, but when it's a 1, kind of still weird, right? So when it's a 1 here, and in theory we could have a case for that, but I want to think of a better way, so I don't have to create a hack for it. There's no need to create hacks. There should be a way we should be able to do that, but yeah, I'll think about that in a second. So so what are we trying to do? Let's decompose the problem. We don't have that much time. It needs to actually be quicker than last time. So we're going to reverse the list and go up to n minus 1, remove the node at the next, right? And this is where things get a bit confusing, because now here when we do start, this is the one condition. When we have like some kind of internal count, the 0 here is equal to n minus 1. So we actually want to remove this node, right? So how would we remove this node? Well, we would just essentially make the head equal to head.next, and then that's it, right? So that'll be the time complexity of this would be order of n, and then order of 1 space, right? Because we're using we're not creating any extra nodes, we're not using any extra auxiliary data structures, we're just using the simple like pointers, which is content space. Okay, so let's first reverse the list. and then we return the head again. But like, are we even incrementing I? Bruh. Oh. Right. Alright, so when it's 2, right, we're going up to n minus 1, so it would be 0, 0, 1, right? Ooh. Because it's 0 index, we have to go minus 1. Right, so because it's oh no. Okay, right. It's starting at 0. So here would be at 0. It would be at 1. So this needs to be 0. This has to be 1 actually. Yeah, so that needs to be 1, and then this is the weird case, right? Okay, so we successfully did it for this. Okay, so for 1, 2, what are we doing wrong? So 1, have to be quicker. 1, 2, we are essentially reversing it, so we have 2, 1. This is going to be 1, right? Let's say 0. We start at 0. So it'll be 0, 1. No, but we have to make it like because it's 1 indexed. So it'll be at 1, which is n. So this is n minus 1. So here we're actually at 1 already. Yeah, so when we're at 1, what do we do? Right, no, that's not the general case. So 2, let's look at, okay, so I'm very close, guys, sorry. Let's look at this really closely. So we have 1 maps to 2. The reverse of this would be 2 mapped to 1, right? And what's n on both of them is, okay, so this n is 1. Well, let's look at the n is equal to 2 case here. So n is equal to 2. So we want to remove this node. So when we reverse it, we will be at n minus 1. So we want to remove this node. So yeah, so we make, so if I is equal to n minus 1, if I is equal to 0, okay, so here in this case I is equal to what? I is equal to 1, because it's never going to be 0, it's going to be 1 always. Wait, I'm kind of overcomplicating it. Wait, give me 1 second, guys. Right, so if it's one, 2, right? So in that case, so this is actually the case that's running. So current.next is going to equal to current.next.next. So that will be this .next is going to be, so it's just going to be 2, which is correct, right? And then for the case where we have this, when n is equal to 1, then we reverse it, and in this case n is equal to 1, yeah, so if n is equal to 1, we want to delete 2, right? We want to delete, yeah, 2. So we say head, which is I'm so slow. Okay, if n is equal to 1, then we want to head is going to equal to current.next, which is going to be 1, and return. So how are we still getting 1, 2 here? Oh, because it never runs. If I is equal to n, that's the case. Oh my god. Yeah. If I is equal to n, then it means we're exactly, that's like the one case. Why was I so slow for that? Anyways, so yeah, we and return head immediately. Why is it still? Oh, because we have to return the reversed of head. Okay, that makes sense. So can I just break instead? Break and then break. I can just break and both of them, right? And then yeah, that's it. Okay, that's the entire solution. Took me some time, but yeah, took me way longer than it should have. 30 minutes. Oh my god. But yeah, let me know if you guys enjoyed this solution. It took me too long actually. It's kind of scary how long it took me. But yeah, what's the time complexity? The time complexity is order of n. It's linear time to reverse the list and do this like removal, because we're starting from the beginning all the way to where we're trying to kind of remove. Space complexity is actually constant because we're using 0 extra space. We're creating no extra nodes. We're deleting in. Yeah, so wait, what? Did I be 100%? Yeah, 100%, yeah. So, yeah, this is constant time, constant space, linear time, and yeah, that's my solution. Yeah. Yeah, that's it. I don't know if I should go to the next question. Oh, what did I do last time? Very curious to see. Sorry, because I done this question before, just 2024, and I did what? Did I do the same thing? What did I do last time? Well, I think it's the same idea, but then I don't know what I've done here. Anyways, I think this is a way more cleaner approach of doing whatever the hell I did here. Yeah, I don't know what I did here. Oh my god. Anyways, yeah, let's copy list with random pointer. Yes, I probably will do this tomorrow in tomorrow's problem. Yeah, I think I'm gonna keep it short for today. Yeah, I mean, if you guys have any other problems you want me to try solving, this problem took me 30 minutes. Like, the coding, this is like the whole point of the whole series, right? It's just to improve my overall thinking process, because yeah, that last edge case when I is equal to n, I should have thought that quicker, but yeah, I just took my time and it was just making a lot of over complications. But yeah, it doesn't matter. We solved it. Took 30 minutes, which was actually faster than last time, thankfully. Hopefully, as we continue to go, it reduces in time. And yeah, that's my solution for today, guys. Hope you enjoyed. And please, if you want more videos like this, please remember to like and subscribe. And yeah, I'll see you guys in the next one. Peace.